Hello, welcome to Econometrics Melody. In this video, we will discuss about the general concepts related with hypothesis testing. First of all, we confirm the distribution of the variable of interest, that is a random variable has a certain distribution. Then after we set our significance label alpha, that is our type 1 error. And if it is a two-tailed test, we divide the extreme left and extreme right region with area equal to alpha by 2, that is half of the significance label. And if it is the left tail test, we divide the extreme left region with area equal to entire alpha. And if it is a right tail test, we divide the extreme right region with area equal to alpha. And for each demarcation line in a two tail test as well as left and right tail test, we calculate their corresponding tabulated score. So let us call it as Z minus Z alpha by 2 for two tail test and plus Z alpha by 2. And for left tail test, tabulated score is Z alpha, and for right tail test it is Z alpha. So in third, we have divided the extreme left or right regions into area equal to either alpha by 2 for the two tail test or simply alpha for one tail test. Then after, we have calculated their tabulated score, and in fifth we will obtain their calculated score. And on sixth, based on the position of this calculated score, we are going to either reject the null or we fail to reject the null. So if our calculated score it lies within this tabulated score, then in this case we fail to reject the null. This region is on behalf of the null hypothesis. And for left tail test, our calculated score it lies within this region, and for a right tail test, calculated score lies within this region. In this case, we fail to reject the null. But if our calculated score it lies in the region of type 1 error, that is alpha by 2 for two tail test and alpha for either left tail test or right tail test, then in that case we reject the null and we make the decision in favor of alternative hypothesis. So let's say for the two tailed case, if our Z score, calculated Z score, if it lied over here, so this is in the region of the type 1 error, then we reject the null and we make a decision in the favor of alternative hypothesis. So for left tail test, again, if our calculated Z score it lied in this region where we have our type 1 error, then in that case we reject the null. And in similar fashion, we can reject the null in a right tail test as well. So for our two tail test, if our calculated Z it lies within minus Z for tabulated and plus Z for our tabulated, that is alpha by 2 and minus alpha by 2, then in that case we fail to reject the null. And if our calculated Z score it lies away from this interval, then we reject the null and we decide on behalf of the alternative hypothesis. Similarly, in a left tail test, if our calculated Z score if it lies between Z alpha to plus infinity, then in that case we fail to reject the null. And if the calculated Z score lies away from these 2 points, then we reject the null. Similarly, for the right tail test, if our calculated Z score if it lies from minus infinity to Z alpha, then in that case we fail to reject the null. And if our calculated Z score lies away from this interval, that is minus infinity to Z alpha, then we reject the null and we accept the alternative hypothesis. So now let us try to understand what does p-value mean. We have set our significance level as alpha, and for two tail test we divide the extreme regions with area equal to half of the significance level alpha by 2, and we can calculate their respective scores. So for the timing, let us consider it as the Z score. So these two, they are our tabulated score. In case of Z score or in case of normal distribution, they are same. So these are our tabulated scores. Now let us say we have a calculated Z score. Let us term it as ZC. So if ZC lies within this tabulated score, then let me mark it as here minus ZC calculated, and due to symmetry it is plus ZC. Then in this case, as our calculated Z, this lies within the interval of minus Z alpha by 2 and plus Z alpha by 2, we fail to reject the null hypothesis. So how do we calculate the p-value in this case? So p-value for this calculated Z score is, so our p-value in this case, this is equal to the area less than minus ZC plus the area greater than ZC. This is called, this is our p-value. As they are symmetric, we can call it as twice the area less than minus ZC, or this is equal to twice the area greater than ZC. So in other words, p-value is like the significance level for the calculated Z-score. Now let us understand this concept for for the left tail or right tail test. So if this is the distribution and if we are concerning on left tail test, so this is our alpha. So this is in fact Z alpha, or we can call it as Z tabulated, the theoretical value of Z. So, and if our calculated Z score, if it lies somewhere over here, let me call it as Z calculated. We draw a line. So the probability of Z being less than Z alpha. So this is our tabulated or Z tabulated. This is what we mean by alpha, our significance level, and the probability of Z being less than our calculated Z score. So this is what we mean by our p-value. As alpha is our significance level, so the p-value is also significance level for the calculated Z score, because alpha is the significance level for our tabulated Z score. So once we know to calculate our p-value, or most of the statistical software, they provide the p-value as well. So for the hypothesis testing, we can base our decision on the p-value. It is very easy. So if our p-value, this is greater than the significance level alpha, then in that case, we fail to reject the null. So this is true for both the two-tailed as well as one-tailed test for any kind of distribution. And if p-value is our less than alpha, then we reject the null. Fail to reject the null, this means we reject our alternative hypothesis, and reject the null means we accept our alternative hypothesis. Now once we know to obtain the calculated score, whether it is Z score or T score or chi-score or F score, we can perform our hypothesis testing. Now let us focus on the scores related with Z distribution and T distribution, that is the standard normal distribution and the T distribution. When the population variance it is known, this is what we mean by our Z test, that is related with Z test. And when the population variance this is unknown, this is related with our T test. Now let us see how to calculate the respective scores for different conditions. So for raw score, our Z test or Z score, we can calculate it making use of this formula, x minus mu divided by sigma. We know this, and the corresponding T score, this is equal to numerator. We have same information, simply we don't know the population variance in this case, and we substitute it by the sample variance. This has a T distribution with n minus 1 degrees of freedom. Similarly, if we want to perform the test for the sample mean, then our Z score, this is equal to x bar minus mu and the square root of variance of the sample mean. And if we don't know the population variance, then this is again going to be T distribution. Numerator we have same information, divided by, here we estimate population variance by the help of sample variance. This is again a T distribution with n minus 1 degrees of freedom. Now let us perform the test related with the difference in the sample mean. So in that case, our Z score, this is equal to the difference of the sample mean. So let me call it as x bar minus y bar, then after the difference in the respective population mean, and we divide it by the square root of the variance of the difference in the sample mean, that is sigma 1 square divided by m plus sigma 2 square divided by m. But if we don't know the population variance, then this is a T distribution, and we will have to make an assumption for this case. Though the population variances are unknown, they are equal. So for this case, our T distribution, again in numerator we don't have any difference, and we calculate square root of the variance for this variable, for the random variable x bar minus y bar, assuming that the variances are unknown but equal. So this is equal to square root of s square p and then 1 by n plus 1 by m, where our this is our weighted average of the sample variance n minus 1 s1 square plus m minus 1 s2 square, and we divide it by n plus m minus 2. Similarly, if the population variances are unknown, but if we can ensure that both n and m they are very large enough, Then the t distribution for this case would be, so the numerator again we don't have any change, so mu1 minus mu2 divided by root under, and in place of this term we are going to simply write it as s1 square by n plus s2 square divided by m. So we are assuming that the two populations are independent. For the large n and m, we are substituting the population variance with their respective sample variance. And if the sample size n and m, if they are not large, then we assume that though the population variance are unknown, they are equal, and we use this statistics. So this is related with z-test and t-test. So this gives us the calculated score. Calculated either z-score or t-score depending on these conditions. And once we know the calculated z-score or t-score, and we can compare these scores with their respective tabulated score, that is z alpha or t alpha, and then we can perform the hypothesis test based on p-value. And the same applies for any other distributions, whether it is chi-square distribution or f distribution. So let us take an example. We want to perform a two-tailed z-test. So for that we divide the extreme left and right such that their area on the extreme is equal to alpha by 2, and we can calculate their corresponding score z alpha by 2. This is what we mean by the z tabulated, or minus z alpha by 2. So this is again z tabulated, and from the above stated formulas we can calculate the calculated z score. So let us say if our calculated z score lies over here, based on the symmetry we can calculate it minus z calculated and plus z calculated score, and the area on the extreme left and right due to this calculated score. This is what we mean by the p-value. So p-value is equals to the area from minus infinity to minus z calculated plus area plus z calculated all the way to plus infinity. This is our p-value. Once we know the p-value, here obviously the p-value is greater than our alpha. For this situation, in that case we fail to reject the null. But if our p-value is less than significance level, then in that case we reject the null and we make our decision in favor of the alternative hypothesis. This is true even for the chi-square test or any other test. Let us see for the case of chi-square test. So we can always calculate it, the chi-squares. Let me call it C for calculated chi-square. This is equal to summation of observed for each observation observed minus expectation square divided by expected. So we take the sum of this for each observations. So this is our calculated chi-square for certain degrees of freedom, and the theoretical distribution, that is to calculate the tabulated chi-square. So let me say that this is the chi-square distribution and it ranges from 0 to infinity. And to perform the two-tailed test, we again divide it into two parts. We have our significance level is alpha, then this is alpha by 2, and this corresponding score, let me call it as chi-square alpha by 2, and here I have chi-square 1 minus alpha by 2. So this is our tabulated chi-score. And our calculated chi-score, let us say it lies somewhere over here. So we calculate it for two values for two-tailed test. Let me call is chi-square calculated, and here chi-square 1 minus calculated. And we can calculate the p-value as well. So if p-value is greater than our significance level, we fail to reject the null. So in this particular case, obviously the p-value is greater than the alpha significance level because we are inside this region from both the sides. So in that case we fail to reject the null. And if p-value is less than our significance level, then we have not quite reached this region from the extremes from both the sides. That is why in that case we reject the null and we accept our alternative hypothesis. So we have covered this hypothesis testing in our earlier videos as well, and let me show it. We have covered a hypothesis testing related with binomial distribution, negative binomial distribution, hypergeometric distribution, Poisson distribution, exponential distribution, Laplace distribution, normal Gaussian distribution, z-test, and inverse Gaussian distribution, which is also called as the Wald distribution, gamma distribution, chi-square distribution, t distribution, beta distribution, F distribution, also called as the Fisher-Snedeker distribution, and Cauchy-Lorentz distribution, logistic distribution, and Weibull distribution. Please refer to these videos for detailed understanding. So this is it for this tutorial. Thank you very much for your time. Thank you very much. Econometrics Melody.